So let's go ahead and talk about proportional and non-proportional relationships. So proportional relationships represent a direct relationship between X and Y. Another way this is going to get asked to you is a direct variation. So if you hear the words direct or direct variation, we're talking about proportional. This means you generate any Y value in a table, you simply are going to multiply the corresponding X value by what's called the constant of proportionality, or K. It's pretty much like slope, it just means we don't have a y-intercept. So there's no y-intercept in a proportional relationship. The y-intercept is simply 0 because I'm not adding anything onto this. So here, all of your proportional graphs have to go through the origin, or the origin means we have a y-intercept of 0. So anytime they ask you for proportional or direct variation, it's going through 0, 0. So the y-intercept is 0. So for example, in this graph, we can create all of the y values by multiplying the corresponding x value by the constant of proportionality, which in this case is 2, or it's the slope. So slope, we just talked about rise over run, so go up 2 over 1, that's 2 over 1. But if I look at this, when the x value is 1, if I multiply it by 2, I get the y value. When the x value is 2, 2 times 2 is 4, well, that's the y value. When the x value is 3, 3 times 2 is 6, y value. You're always multiplying by this constant of proportionality. So here it is in the graph. Negative 2 times 2 is negative 4. Negative 1 times 2, negative 2. Well, aren't these the points on the graph? Negative 2, 4. Negative 2, negative 4. Negative 1, negative 2. And then 1 times 2 is 2, and that's on the graph as well. To calculate proportional relationships from a table, you're going to divide y by x, and if the number is the same, the relationship is proportional. So here we go, 6 divided by 2, well, that's equal to 3. 15 divided by 5, y divided by x, is equal to 3. 27 divided by 9, also equal to 3. Since after I divided all of my y values by my x values, it is the same number, which is 3, that's called your constant of proportionality, and it is proportional. If I was to write an equation for this proportional relationship, it would be y is equal to 3x. So it is proportional. So we're going to decide whether these are proportional or non-proportional based on looking at the graph in the table here. So here I can see that this graph goes through the origin, so it is proportional. The second it goes through the origin, it's proportional. For this one, we're going to divide our y values by our x values. Well, we have negative 1 divided by 1, that's negative 1. 2 divided by 4 is 1/2, and 6 divided by 8 is 3/4. So that is not the same number when we divide them, so it is not a proportional relationship. Here I have y equals 4x. Well, if we're thinking about our equations in the form of y equals mx plus b, I have an m in this situation, which is 4, but I have no b. So that means b must be 0. So it is going to be proportional, because if b is 0, that means our y-intercept is 0. And then looking at this one, the graph does not go through the origin, so it is non-proportional. If you are given a situation where you have words to decide between, like this one here, you're looking for any kind of starting point that would indicate a y-intercept, so therefore it is non-proportional. So this one says the total number of text messages sent if 4 were already sent and 6 messages are sent per day. Well, 4 already sent, that's a y-intercept, so that's non-proportional. The number of characters in a text message if each word contains 6 characters. Okay, there's nothing about a starting point here, so that one's going to be proportional. Okay. And then it says the number of minutes it takes to enter a text message at 50 characters per minute. Well, no starting point again, so that is proportional. The time it takes to send a text message if it takes 30 seconds to open the app and the sender enters 1 characters per second. Okay, well, that 30 seconds it takes to open the app is going to be a starting point here, so that is a non-proportional relationship. All right, I hope that clears up proportional and non-proportional.